Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. Today on the bench I have a Sony ST-636. This is a really unique tuner. This is a client unit. He brought it to me. He bought it. He actually was on a search for a tuner for his system, and he found this one. And I think it fits all his, ticks all his boxes. And he liked it, and he got it. He bought it, and he brought it to me to fix up. I don't know if there's anything wrong with it, to tell you the truth. I think it does work. But we'll go through it and make sure everything's 100% before we return it to him. I see there's one problem here. The dial glass is pushed in. The glue's it's loose and pushed in, so that the adhesive let go, so we'll have to fix that. Anything else? Looks like it's just dirty. It's a really nice unit, and it's really unique in that it has, it's like an analog digital computer. Well, it's called a computerized crystal lock synthesizer, and AM/FM programmable tuner. It has all the cool Sony innovations in it, I bet, for the day. Now, I was doing a little bit of research on this. I was looking it up, and this comes part of a suite of Sony equipment. The ST-636 is the power amplifier, matching power amplifier for this, and it has LED power meter on it. It's got the same kind of knobs and same look. And I did have a Sony ST-535, and it was similar with the power meters and the look. I think if you go back, I can't remember what episode it was, but it was in early years of the channel. I had this Sony SA535 featured in one of my videos, and I used to have that as my garage amp for a number of years, and then I decided to recap it and go through and fix it up, and it never did sound good. It just sounded like a pile of crap, so I scrapped it. So this tuner has a unique look, and we're going to try it out. Let's try it out right now. I don't have any audio plugged into it, but we're going to try the power. Pretty sure it does work. Turn it on, and we're greeted with two vacuum fluorescent displays. One over here has the digital readout of the signal of the station and a signal meter, and then this is like an analog dial, and we can tune this to making a ticking noise. Okay, I get it. So it's got a multiple accelerated scanning. So if you go, you can do one tick, or a slow tick, or a fast tick. So you can. Cool. Stereo, AM/FM. Okay, here's AM. And then we have presets. There's red indicators where the presets are, I believe. Cool. Auto. And it'll scan the band for you. I don't know if you can see this. Maybe if I turn the lights off, it'd be. See, it's doing its auto scan thing. Let's go AM. Same thing with AM. I don't think there's an AM antenna on the back. Oh yeah, there is. There's a bar antenna on the back. So it should pick something up. We get down around, there we go, 9:30, it locked in. Okay, let's go look for the next one. 880, that's correct. 740, 740, and then 630. Cool. So everything's working on the AM. I think 580. There was one there, but it missed it. Okay, good. Let's have a quick look at the controls. So we got a power button on the left hand side, and then we got this giant vacuum fluorescent display tube. It's probably about 9 inches long, it looks like, and it's got all of our dial scale on it for AM and FM. Down here we have our mode switch for stereo mono, and then it's got AM FM muting, so when it's in the stereo mode it will mute your interstation hiss, which I don't like that. I wish they would separate these out, because why put two functions on one switch? I don't see why they should do that. They should, if you want to make a nice receiver or tuner, put these separate. Have another switch here for muting, and then we can decide when we don't want muting. FM, AM, so these are just to toggle between AM and FM, and you can see here on the left hand side as I toggle between them, the indicator light here goes, and then the tuning indicator changes. Auto, that's your auto scan with an LED. Here we got our display, signal strength and frequency display, and stereo lamp, and a tuned lamp. So let's see here, we are tuned to 580 right now, but it's a weak signal. Let's go up. And it missed 630. Let's do this. Okay, why is it missing 630? It shouldn't be. The tune light is kind of flickering on and off. It should be getting better. Let's go up to 740. And then we got a stronger station that's tuned. Okay, that's working. And we have our programs, 5 for AM, 5 for FM, it looks like. Alright, on the back we got a bar antenna. And we have inputs for AM long wire, FM 75 ohms, FM 300 ohms, and then we have a 75 ohm coaxial input, which is nice. I have a Sony proprietary remote control connector. It's got 6 pins, probably flows through to an amplifier or something that controls this. I don't know anything about this. And then we have our output, which is not RCA plugs, jacks, but we have this silly arrangement. I don't know why they did that. Put a cord on there that is not removable. That's kind of unusual. Power input, our tags, and then we have a switch here for switching between 10 kilohertz steps or 9 kilohertz steps. There's just a little toggle switch here. If you're in Europe, I guess you would flip that up. And if you're in North America, you switch it down. Consumes 28 watts. Let's see. What do we have here for consumption right now? It's on. So we're under 22 watts. Not bad.
I was so worried that...
Okay, I'm going to use the Harman Kardon 330C to help us out here today. Feed some audio through it. So, from what it sounds like, everything's working.
Ear patterns that we couldn't hear using just our scientific...
$3 billion to have a 30-year contract to provide a monopoly on doing land transfer services.
Okay, AM seems to be working fine. Let's try FM. Oh, there's no antenna. Let me hook an antenna up here. Alright, got an antenna hooked up. Let's try it out. It doesn't want to scan. And it's overwhelmed with
dans l'exposition.
Doesn't seem to want to pick up stereo too well. We have it on stereo.
Or his best.
Doesn't want to.
In 2003, when I moved to Alberta,
And I got a nice strong signal connected up to it, and it should be full bars and stereo signals, but we're not getting any stereo here. Not hearing any separation. Whoa, what's going on here? Oh, sorry. I saw the watt meter jump up and I forgot that I had this connected. No stereo. See, now that's full bars, and there's no stereo signal here. Maybe a dirty switch, maybe? No, it's not coming in at all. So we're going to have to do a little bit of work to this thing, I think.
Counter BLT. You've got B.
I did see the lamp come alive when I was down at the low end of the band, and it was interstation noise. So maybe all it needs is just an alignment. It might have a defect too. I did see the lamp come on. Let's try the top end. I got a really strong station at the top. Nothing there.
It can feel like your world's turning up.
It's got a funny mute thing.
Come to J&J Auto Works. They provide honest service, free diagnoses, a low labor rate, and real pricing on parts. Get your vehicle the way it should at J&J Auto.
Okay.
Outdoors Comedy Festival.
Alright, I think I have a good idea what it needs. Alright, first reveal. Looks good. A little bit of a stain there in the middle. I don't know what that's from. Wow, this thing's just packed with stuff. A lot going on here. So this big board here in the top looks like it's a driver board for the analog portion of the vacuum fluorescent display. A lot of transistors. Look at these are all transistors. Every one of them. There's like 20 of them here, 20 of them here, another 20 here. So there's a lot going on. It's a lot of discrete stuff. They're all drivers, I guess. This is an IC here. Dial pointer driver, band indicator driver, FM marker driver, dial power driver. So all this board is dedicated to that display. On this side we have a little board that's looks like it's driver for this display, the frequency display and the signal strength. So this is a driver board for that. If we remove those two boards, a fairly beefy power transformer, because this thing's going to consume, you know, like they said, 25 watts. So that's about right. And then they have a mains filter here, common mode choke, and EFI filter. Probably because there's a lot of noise that's generated inside here, and they don't want it getting back out on the power line. The whole bottom of this thing is just one massive board. You can't really see it. Let me see if I can spin this around. Yeah, there's a board, and it's pretty much the whole width of the receiver or the tuner, and it goes from front to back. So it's a huge board. It's covered with chips and power supplies, and it's all power supply down here. Looks like there's a few cooked areas, and there's some cooked caps. I can see those already. So I don't know what's going on there. There's some big chips down below. Yeah, it is quite involved. Quite the tuner Sony made here. Let's see if the bottom, I think the bottom will come off too. Let me have a look. Okay, here we go. Looks fairly clean. Like I said, here's that huge printed circuit board on the cover, on the bottom portion of the tuner. I'm looking here and I see right around here, this is power supply here. There's some cracked solders on this for sure. There is definitely cracked solders on this. You can see them all over the place. Okay. And this is all microcomputer, it says. Memory circuit, digit circuit, gates, accelerated tuning, phase lock loop. I like Sony's. I like how they mark their boards. They have part identifiers for part numbers. They have the sections all boxed off, so when you're servicing, you know that in this box, that's all for that one circuit, and you can focus your efforts there. Back here, it looks kind of dicey. They have NiCads for memory backup, and looks like they leaked, and there's corrosion all over here. So this will need to be repaired. And then they have a little annunciator that does the little ticks when you're tuning up and down. That's cool. Yeah, this is going to need some work, I think. You can see something going on here. Looks like corrosion or something. Looks like somebody who's been removing parts. Okay. I think the first thing to do is get all these dead caps. There's probably dead caps in the power supply for sure. And I was looking at the top of it, and it does look like there is a lot going on here. There's a lot of cracks on these transistors. I can see them all over. I don't know if you can too. Let me try and zoom in. Just don't know if you can see some of these cracks around this one. This transistor, these two are cracked. This one's cracked. Yeah, there's... Surprised it even worked. This one's got two cracks. This one's got two cracks. Yeah, interesting. Alright, so I removed the front panel, front face, and I removed two screws here holding this assembly in place and pulling it out just to reveal the underside of the board. There's a lot going on here. Now, I'm kind of disappointed they don't have plug-in connectors. Everything's wire wrapped and it's all connected. I can't just take this module out and service it separately because it's all in, you know, just to undo all these wire wraps is crazy. And just look at all these transistors. There's like 100 of them. A couple hundred anyway, looks like. I didn't count them, but look at them all. Just wow. And then your two main logic chips. There's lots of logic chips under here too. Now, I'm going to protect this vacuum fluorescent tube. It's very fragile, and I don't want to have any screwdriver hit it or in that, so I'm going to wrap it in foam and tape it up. But I just wanted to show you the cracked solders on this thing is incredible. All the way down this vacuum fluorescent tube, these are all cracked up to about this point. And then there's some more in the middle, and then there's a few others, and then on the other side, same thing. And that's common on vacuum fluorescent tubes because they have the filament in there, and they slightly heat up and expand in length. And what happens is these ones on the outside crack first because of this very, very small amount of expansion contraction every time you turn it on, turn it off. And these crack with time, right, over the thousands of cycles. And so I'll have to resolder all of this. Now there is some warnings about static electricity in the service manual, but you'd probably be okay if you leave everything connected to each other and don't go crazy with poking around with probes and stuff. So I'm going to get some foam, tape it on here just to protect this and keep it from getting damaged. And then I can start servicing. I'm trying to get to this power supply because part of the areas here are cooked pretty good. So this piece of foam should work. I'm just going to get some masking tape. This underneath here. Attach it to the side. Yeah, I just want to protect this because there is no cracking this tube, there is no turning back. And make sure we secure this. Okay. It doesn't want to stick very good. There we go. Alright. That should help. I'll put some more tape on there. But that's what I want to see. Another thing I'm going to need to do is remove these two struts because they're right in the way, and can't really solder underneath here, so remove those and then we're on our way for fixing this thing. I might just remove this too, so I don't want to get it scratched. Just take this out, and then I got peace of mind knowing that it's not going to get scratched by an accidental slip of the soldering iron or screwdriver. Oh, it's glued on. Let me get a knife here. There we go. I don't want to bend this, it's just aluminum. So very carefully peel it off. There we go. I think we got it. Almost. There. Yeah, that's going to need to be cleaned. Kind of gets foggy with age, the dust. So I'll put this aside and then we can work on the rest. So I'm just starting off on the power supply here, and what I'm finding is all the caps are bad, believe it or not. Values have dropped considerably from what they should be. I had a 1000 microfarad cap, it was down below 750. Here's a 47 at 35 volts, and it should have an ESR of about 700 milliohms, but it's up around 2.7 ohms, and it's down in value a bit. So this is pretty typical. All these caps are cooked in this power supply. I'm going to keep going, and if I continue to find caps like this all over, I'm just going to redo everything. But for now, I'm just concentrating on the power supply. I have a feeling once I get away from the power supply, the caps will start getting better. But this is typically what I'm seeing. So I finished recapping the power supply, and I'm going around. Starting to work my way into the tuner portion, and I've decided, well, I'm going to check some of these caps that are far away from the heat here, and I'm pulling them out, and they're still bad. So here's a 47 at 16 volts. If you can see it up there, it's should be half the ESR. It should be down 1.6, not 3.3. And as the cap cools down, the ESR keeps climbing. Microfarads goes down as it cools off. These caps are done, and these are good quality Elna caps too. It's a shame that I got to pull them all out and replace them because they're failing, and you can't run with these. You could run with them, but 6 months from now they would be a lot worse. So yeah, they're all going to get replaced, I think. Doesn't look like there's too many in here. Well, like I said, I did most of the power supply already, and yeah, I'm through maybe 20 caps. But and keep going. One thing you always got to be on the lookout is for stuff like this. They have these leads and they're trimmed, and sometimes they fold over. This one's not touching, but it does look like it is touching. I'm just going to bend it back. Now, I think what they do is they run the bottom of the board. Once it's soldered, I think they run it through a machine, and it kind of like a hedge trimmer. It just trims everything off the same length. But some of these are quite long. If you look over here on this area, you can see there's some quite long ones, and they're approaching about 4 millimeters long. And if you tap one of these or knock them, they can fold over and short on each other, so you got to be careful of that. Sometimes if they're long like this, I like to go through and trim them all, but there's so many here, it may take me all day. But if they're really long, I trim them, because they don't need to be long like that. It's just an opportunity for a short circuit. So I don't know, I might trim some of these longer ones, but to do the whole board, it might take me quite a while. Alright, so let's get started on this. I don't know if you can see these cracks. They're all cracked. Seems like every one of them, but for some odd reason it was still working. Go through and redo all these. The hole wants to open up because the crack is there, and it separates the solder. Separates the solder from each other, and then when you heat it, the solder wants to ball up and it flows away from the crack, and then the crack opens up. You get a hole, so you got to flood the joint so that the hole's covered. Sony went through a lot of effort to build this vacuum fluorescent display, and incredible expense of building it, and well, designing it and building it. And then building a tuner all the way around it too. I think they probably, I don't know if they used this same tube in some of the receivers. Maybe you guys know better than I do. I'm not big on Sony equipment. I don't know much about them. But I do know like they like to be innovators and leaders in this kind of stuff. So wouldn't surprise me they put this tube in a receiver as well. Okay, I'm about a third of the way through. I give the board a good scrub when I'm done, get all this flux off. I find it's really difficult to inspect a joint when it's all covered in rosin flux and it's all brown and dirty. How are we making out here? About halfway through. This is the tedious stuff that takes the time when you're doing work on something like this. But it's got to be done, because you can't leave it like that. What you'll get is segments of the fluorescent display flickering and coming on and off, turning and disappearing and coming back on. And you'll find it's temperature sensitive too. When it's cold, your display might work in some areas, not others, and then when it warms up, that changes. It's all because of these cracks and the temperature and the expansion and contraction. Oh, this one looks good. There's one good joint out of all of them. Or maybe, yeah, there is a pin there. So I'll go through, you don't need to watch the whole thing, I'll go through and finish this up. So typically on these vacuum fluorescent display tubes, the last pin or 2 pins, maybe 3 sometimes, depending on the design, that's the filament. And when these ones crack, the display goes blank, and you see nothing because there's no heater, voltage on the heater of the tube, and the tube stops conducting electrons when the filament goes out, and then your tube goes blank or dead. So these are the ones that usually crack first, the ones on the very end. Okay, so I'm done with the recap, and that went well. It's fairly easy. Pretty much everything's on the main board. There was really no caps on the other boards. There's one on one, and I think there's none on the other. This one with the vacuum fluorescent display doesn't have any caps. Or it has one. Oh, I'll have to get to it. I didn't see that one. But anyways, power supply section. You can see here there's 3 caps missing, and that's because I mounted them on the bottom. Let me flip this around, you can see. So I just mounted these caps on the bottom, and I'll anchor these with some neutral cure silicone just to the board, just so that they don't vibrate or break with any vibration. And I'm going to cut off all the leads now, and I still have to, you can't see it, still got to clean up this mess. They have transistor, resistor, diode, 2 caps. They built a little circuit down here, and this is a bodge. So I'm going to remove this resistor, put in a chip resistor, get rid of that. I replaced this cap already. This transistor I'm not going to do anything with, it stays. This cap I need to replace yet, and this diode I'm going to replace maybe with a surface mount, just because they got that nasty glue in here and things are starting to corrode. If I pick out all this glue, you can start to see the damage that was done. So I'm going to clean this all out, fix it up, and replace these couple of components, and then that'll be done. But yes, the recap was needed, because pretty much 90, well, let's show you the caps. So here's all the caps I changed out. Actually, not that many. Not that many. But I'd say about 4 or 3 caps I pulled out actually tested good. The rest of them are garbage. High ESR, really out of tolerance, and just it was necessary. These are Elna caps, good quality caps, but this is like an 80s machine, I believe. I don't know if there's any date codes on these chips. 8, I'm seeing 8, 9. Oh, 8044, there's a date code. 9266, that can't be right. 8044. So I'm guessing this is a early 80s, mid 80s tuner. But yeah, we got problem caps here. Alright, I gotta clean this mess up now. This annunciator is kind of in the wrong spot. Glued down. Look at all the corrosion and stuff going on here. So what I'm going to do is clean this up. All this corrosive glue, and the battery leaked. Now they have 2 what looks like NiCads in series to produce a 2.4 volt battery. This is your ground and this is your positive. And then they go through a 330 ohm resistor right here. I think that's what that is. Maybe it's just a jumper, but then it goes back and then it goes to the memory, which is way over here. And this is our memory backup. And some nasty stuff going on here. So I'm going to pull out this battery and clean this up. See if we can do something with this. There it is. I don't know if these batteries are any good. I don't think they are. Let me check them. Let's see here. What do we got? Can't read my meter. Half a volt. It's no good. This one's 0. Nope, it's 1 volt. So they're probably good. Maybe they're just dead, but I'm going to replace them. What I'm going to do is I'm going to make it more user-friendly. I'm going to take a battery holder like this and mount it somewhere up top, and we can drop new batteries in if they fail. They're easy to change. You don't have to solder the board and destroy it like this. Now, I think it's important that when you're using, well, these are NiCads. I'm assuming these are NiCads. They might be nickel metal hydrate. But I'm going to use, not NiCads, but I'm going to use the nickel metal hydrates. And they're a little better. And positive here, negative here. It's pretty easy. Clean this up. Yeah, it's important that these batteries never go dead, because once they go dead, they don't want to recharge. So if the tuner's in use, regular use, they will always stay recharged. From what it looks like, there's a 5.8 volt line that feeds the circuit, and it feeds the memory chip back up here. And then there's a diode drop, and then it goes through the resistor to the batteries, which gives it, supplies it about 5 volts to the resistor, and then keeps the batteries charged. 330 ohms. I could do the math on that. It's probably, if I do the math on it, let's try this. Here's a look at the charge circuit for the NiCads. So this red line here is supply power, and it's probably it says 5.8 volts on the schematic. And then it, like I said, it goes through a diode drop. And this diode is to prevent this battery from backfeeding into the tuner, and it's only going to supply this RAM chip here with power. So 5.8 volts goes through a diode drop, so it comes out at about 5.2, 5.1 volts, and goes into the TC5501, which is probably a Toshiba RAM. Let's see, and then here it goes through a 330 ohm resistor. This is to limit charge current, and then we got our two batteries in series to ground. So pretty simple circuit. When this is supplying power, this pin has 5 volts, and then when power dies, this 5.8 supply voltage disappears, and the battery starts supplying 2.4 volts to the RAM chip to keep it alive. Okay, so we have a 5 volt supply minus the battery voltage, which would be about 2.4 for 2 cells, equals 2.6 volts. Now I equals E over R, so 2.6 divided by 330, and that'll give us 7.8 milliamps of charge current. That should keep the batteries fully charged when the unit's in operation. So that should be good. So we'll go with that. I gotta change this cap. Alright, so there it is after I cleaned it up a bit. I've been scraping away at it. Glue and corrosion. Now this area here, this trace here I don't care about, we're not going to use it. And this ground plane here we're not going to use either. So if that corrodes away to dust, I don't care. I'm only concerned about this connection here. I'm going to attach my wire to this pad and this pad for the battery. And I'm just going to scrape this back because this heavy corrosion right here, it looks like it might be too far gone. Not much copper left there. Which is no big deal. I can attach the wire anywhere in the circuit. It doesn't have to be here. I just thought if I can save this little pad, I'm just going to scrape it down to bare copper, and I'm going to tin the whole thing so that it stops corroding. Get a little flux on there. Let's get some solder, and see if we can do something with this. Doesn't really want to accept solder. There it goes. That should stop the corrosion, hopefully. Clean all this crap off. Okay, that's going to be my positive battery connection. Oh, this trace here, I want to fix that up too. It had a little bit of corrosion on the back of it. So I'm just going to scrape this down to bare copper as well and just tin this so it stops corroding. It doesn't. Just going to scrape it down until we get bright shiny copper. Doesn't. I'll try that. If this trace breaks, then all things will go weird. Oh, that's better. Okay. The rest of this I don't care about. It's out of the area. Look at this cracked solder right here. Another one. They're all over. Okay, I'm gonna figure out what I'm going to use for batteries, and then I got that changed, and then I'll get them set up and ready. So for cells, I'm going to use these Panasonic. What are these things? HHR-4 MRA 1.2 volts. These are nickel metal hydrate. You can read that. I don't know if you can read that. It says up to 780 milliamp hours. Well, we're going to see that, how much that is. So we're going to put these in, and what we're going to do is we're going to do a charge refresh on them. Okay, so we want discharge refresh. Okay, and current is at 500 milliamps, that's fine. And we'll just let that go. What this is going to do, it's going to discharge the battery, charge it up again. And I'm not sure if it does it twice or 3 times. It takes probably about 24 hours, and what it does is it puts it full discharge, full recharge, and it measures the milliamp hours, and then it will tell us what it is, and we're done. And we'll use these as our memory backup batteries. So I'll let this sit aside and let it do its thing, and we'll get on to other things. Okay, since we're changing from nickel cadmium battery to nickel metal hydrate, I just wanted to look at the data sheets for batteries and see if we're doing things right here. This is from Panasonic. This is a handbook for their nickel metal hydrate. And oh yeah, we got certifications, everything's good. And oh yeah, green, everything's green. But this is what I'm interested in right here, charging. Now, what we're doing is we're setting this battery up for trickle charging, and it says right here in this box, right up here in the top corner, it says trickle charging cannot be used with nickel metal hydrate batteries except specific high temperature batteries. However, after applying a refresh charge using a rapid charge, use a trickle charge of 0.033 CMA to 0.05 CMA. Also, avoid overcharging with trickle charge, which could damage the cell characteristics. A timer measuring the total charge time should be used. Now, they don't want you to trickle charge these, but we're going to see. We got this 0.033 CMA, so let's try and see what we have. We measured 7 milliamps, or we didn't measure, we calculated 7 milliamps. So if I go 0.033 times the 780 milliamp hours of the cell, let's see here, we should get 25 milliamps, and we're only down at 7. So we might have to change that resistor from a 330 ohm to something that's more friendly for this battery. Let me see. We had, let's clear this, we had 5.8 supply voltage minus the diode drop equals 5.2 minus the cell voltage equals 2.8. I equals E over R, so R equals E over I. R equals E over I. 0.025 milliamps, and we're down to about 112 ohms on that series resistor from 330. We might, what I'm going to do is I might change this resistor to 120 ohms from 330, and that should give us enough current so that this will at least charge properly, according to Panasonic, on trickle charge. Now we don't want to overcharge them, so we don't want this current too high. So I think 120 ohms will be good. It'll be less than 0.033 CMA, but it'll still be better than what it was. This is quite a good document to go through and read if you want to learn about nickel metal hydrate batteries and how to use them and how to keep them safe. Charge, discharge characteristics. It's a lot of information in here. It's a good read if you're into that kind of stuff. It's worth going through. Where are we here? We're doing these ones. No. Well, these are data sheets for individual cells. I don't know which cell we have here. None of these. I don't see my cell here. How to make up battery packs. This is good information too if you're building a battery pack for a device. It's got some information in here. Get the ones with the solder tabs. Yeah, a lot of good information. Alright, what I'm going to do with this annunciator is I'm probably going to mount it up front here. I'm just trying to think of a good spot. I don't want it in the way of any buttons or anything else. There's an area here where there's nothing, so I could mount it down here. I think what I might do is just drill a couple little holes and get little nut and screw, and just mount it there, and then run the wires under to the circuit board. Not that I want this louder by any means, I just want it out off that printed circuit board because it was glued to the bottom with that nasty glue and it was doing damage to the traces. So we're going to mount this up here, I think. I'll just drill a couple holes. Alright, this dial glass is just held in place with double-sided sticky tape on both sides, and then they ran a little bit of glue, that nasty glue that corrodes everything. They ran some along the outside just as security, but I could use double-sided, get out of there. I could use double-sided sticky tape, and it would probably last another 30-40 years till it dries up, and or I could just cement it down with some epoxy. I think I might just do that instead. I'll clean up all this other old adhesive, drop it in place, and then we'll run some epoxy resin, probably UV curing epoxy resin around the outside here, and just to hold it in place, and that should give us a good bond. I was looking for a spot to put the battery holder, and I think this shield goes up here on this back panel, and it shields the input from all the digital noise. I think I'm just going to mount this battery holder right up top here. I don't want to get in the way of these adjustment holes. I think I'll just mount it like so. No, I think like this, and I'll mark a couple holes, drill, and I'll mount that right there, and that's where our batteries will be. So my batteries are done. Took about 5 or 6 hours. Just want to see what we got here. Here's our battery voltage, and there's our milliamp hours, about 400 each, down from 780. Okay. Ooh, they're warm. Alright, been busy doing stuff here. I got the dial glass glued back in. I used 2-part epoxy, 5-minute set for that. I didn't want to use UV cure. Even that has its challenges with the epoxy, because you got to be ultra careful you don't get crap on your hands and then touch the glass, and it would just ruin it. Everything else is done. The front's put back together, and everything's done here. The wiring's done. I got the battery holder installed and wired in, and I have the new, or that the transducers moved to this location. So I think we're going to do first power up. Let's plug it in, and we'll watch it fly or fry. Went up to 22 watts. We got full display. Looks like we have full display. Well, you know what I forgot to do? I forgot to put the LEDs in, so I need to take that cover off. So let's do that now, and then we'll come back. Yeah, these are the LEDs I'm talking about. I forgot to connect them up. Just put it in the hole. It should snap into place. There we go. Come on. Why do they do this? They only give you like an inch extra, right? Because they're trying to save costs. I couldn't put 4 inches on there for you. Alright, put this back together. Okay, take 2, this time with LEDs. So what do we have here? The auto LEDs working. AM, FM. Push memory lights on, okay. We're on AM right now. No, FM. No antenna. You notice a problem here? Look at this pointer. Now we have 2 pointers. So we have a short somewhere here. And it's making a duplicate phantom. So we have to take a good look at this. Maybe when I was resoldering I made a mistake. Alright, let's have a close look at this. I'm turning it on. Let me turn some lights off. Maybe you can see it better. So, our problem is we only should have 1 pointer, not 2. And when I scroll through the band, it moves. And they move in unison, right? That's important. Remember that. And I click, 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 go down, go down, go down. And then once I get to a point, it disappears. And I'm on a new section here. And it's independent, like it goes by itself. So what's going on is we have grids. I think there's, I can't really see, there's one here, 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 and here. I think there's 2 more. Now, each grid controls, well, this is like a strobed display, right? To get things to light up, you have to have a negative voltage on one plate and a positive voltage on the other plate, and then it illuminates. And your grid is what shuts it down for that moment. It's multiplexed because these connections, these bars here, you can't see, I'm not pointing in the right spot. These bars here and these bars here are all tied together and they're strobed on at the same time, but each grid, only depending on which grid is on, you'll only see the light. If the grid's off, you won't see the light on all these other ones. I don't know if I'm explaining it right. It's multiplexed. So if we go up on the band and we get to a point there where it doubles, so between 96 and 98, and if we go up higher, you'll notice that it goes to the end of the grid. And this one disappeared because it's onto the next grid. It should be the next grid, but these 2 grids are shorted together, so it falls back onto this one again, and the thing starts right over again. So these 2 grids are shorted together. Let's go look at the schematic. Okay, here's our display, and this shows the construction of the grids. It's got 9 grids in it for all these segments. Now, our problem starts right around here and ends right around here. So it tells me G5 and G4 are shorted together. They have the same potential. That's why they're always doing the same. They're mimicking each other. Okay, so if we go down here, pin connection G4, where is it? G7, 6, G5, okay, pin 38. Pin 38, pin 42, and pin 45. Okay, those are G5. G4 is 47. Writing them down right now. 51. 51, and I think the last one would be 55. Okay, so I'm going to have to go back and do some wire tracing and some tests. What I want to determine is if there's a short between G4 and G5. There's lots of jumpers and traces that go everywhere, and we'll have to figure this out. Alright, I hope you can see this. It's going to start getting hairy here pretty soon. So I went on to the vacuum fluorescent display and I checked the pins for those grids G4 and G5, and I ran continuity checks between the pin and the buffer or driver, and I did continuity checks between grid to grid, and it was open grid to grid. There's no shorts there. So whatever's happening is happening before these buffers. And these little triangles here are just telling us the buffer. These are like these triangle with the number beside it. For example, this one has 20. I'll go up and show you what 20 is. If I go here, I can show you. This is transistor number 20, right? And it's a shaded out triangle. So this is the kind of buffer that it is. These are the standard values in the buffer. Each one has the same values, and then the 20 means that's transistor Q 620, 620. Sorry, yeah, 620. And that's the 600 series, 700 series. So I went back and checked these transistors. These transistors are okay. So now we have to go farther back than this. Now if we look on line 42, which is grid, I can't remember which grid it is. 42 is grid 5. It goes through transistor 20 and goes to line 30 and then goes down to off. And then if I look at grid 4 is at pin 55. Pin 55 is grid 4, and that goes through transistor 19, connection 31 into the bus. So where does this go? Let's go look for it. So it goes right here to this. This is actually fluorescent display number 2. And these lines 30, 31, 32, and 29 goes to these these are pull down resistors. Either pull down or pull up, I'm not sure. There might be a short here somewhere. I'm going to have to go back and check on the other board. There's either a short or maybe there's an open. I don't think it would be an open wire. It would have to be a short. Okay, this is what I wanted to see. These lines come in, 30 and 31, and then there's these buffer transistors here, and then this chip. So this decoder chip might be bad. This is a TC4028. That's just CMOS. That might be the problem. We might have a short between line, which line would it be? 4 and 5 on a chip, which would be pin 1 and 6. Yeah, but wait, there's more. These pins are also connected to these lines here, 14 to 18, and they go down. Let's go follow those and find out where they go. We could have a short on one of those too. Where does this go? Oh, look at this. This goes to here. You can't see it. I have to go down. And this is for the board. There's a bunch of diodes here. So maybe one of these diodes could be bad. That would be between pin Where are we here? Between 14 and 18. So between 14 and 18 we might have a short. Could check here as well. I got powered on, and we're going to nose around with the scope here and see what we can see. So let's try pin 55 first. This will work. Stupid ground clip. What can I ground it to? Come on, cooperate. Okay, 50, 51, 52, 53, 54, 55 right here. Okay, let me just get the scope. What the hell are you doing? Okay, 55. So we got 2 bumps there. And let's see, what's the other pin? The other pin is 42. And this is not easy. Try and be careful with this tube. 42 is here. And we got 2 bumps. Now I checked between those 2 grids, there's no connection. So it's not there. It's good. So let's go back. Follow 55. Here. To here, to here, to here, this one, right? Yeah. This one? No, it's not that one. Right here. There. Yeah, that one. That's a collector of Q619. Okay. If I go to the emitter is high. All the emitters are connected together. Base. Let me look at the base. Turn up the volume. Where were we? Base. Come on. Did I lose my ground? Collector. Base. Well, it's there. Believe me. Trust me. Now if I go to the other one, 42, and I follow it through, it comes through here to here. These lines run right next to each other. That's why I thought they might have been a short. But I didn't measure a short anywhere. That one's got single pulse, double pulse. 42. Okay, 42 goes a different path. This is 42 here. And then it goes up to Q620, the collector. Okay, that's correct. And then the base. Okay, let's follow that signal from that base. And let's look at a few other signals here. Let's find IC515. Those are buffers. I think it's on the main board. IC515. This is all 600. Okay, I'm going to flip this over. Yeah, it's down inside here. 515, 505, 506, 507, 8, 9, 10, 11, 16, 14, oh, 512, 13, 14. Oh, there it is. It's right with the lines 30 and 31. Let's scope this chip. Hang on, I got to deal with this. Have to make sure that's safe before I turn it on. Okay, on pin 515, we want to see if we have a signal flowing through from pin 5 to 11. So let's turn this on. It's pin 1, 2, 3, 4, 5. It's pin 5. Looks like a good signal. Pin 11. Here's pin 11. Oh, hang on here. We have a double signal. It's like a ghost. Let's go from pin 4. There's pin 4. Good signal. And comes out on pin 12. Let's see, pin 12 right here. We've got a single. So maybe this chip is bad. That's the output, pin 11. Output, let's see here. (16, 15, 14, 13). Pin 12. Pin 11. Why do we have... Let's try pin 4. That's pin 4 and pin 5. Okay. Pin 9, 10, 11. Let's see if we got a short here. I'll shut this off. I'm just going to flip this back. It could be this wiring harness, I don't know. Pin 1, 2, 3, 4, 5, 6, 8, 9, 10, 11. Yes, we have a short between these two lines. Okay. Short comes back here. 2. That's really odd. I don't see any reason why it would be shorted. Unless there's something going on in this blob of wiring that I can't see. I don't think so. I don't think there's a short there. Unless it's these goofy... No, can't be those goofy things. Huh. Let me check into this deeper. I see 515 is right here. Pin 1 is here. So 16, 15, 14, 13, 12, and 11. Got a short between those two. Now, is it the chip or is it the was connected to the chip. Let's use diode check here and see. Showing a short. What I'm going to do is I'm just going to lift the legs on those two pins, and we'll see if that short stays or if it goes. Let me get some solder braid here. Let's get rid of the solder on these two joints. Okay. Where is the short? Okay, it's not the chip. So that goes back onto the other card, and we have to go back there and look because there's nothing wrong with this. I'm going to solder this back up. So something is wrong here in this circuit, and I can't see anything shorted on the back here. You don't have any solder bridges. I've checked this multiple times. So let's see if we can figure out where this short is. Well, hang on a second here. These are the diodes. If I solder one of these diodes, so it's not the diodes. Something in this circuit with this cable. Something is weird with this cable. I just can't see anything wrong with it. It's not shorted. Let me poke at this. Okay, it looks like I deserve the idiot award today. Look at this. Wow, it's really stuck in there too. Now I cut all these pieces. Oh, that one is just folded over. Aha. Okay. There it is there. So now we're getting somewhere. Alright. Hopefully that's the end of that. And just to confirm, it is work. Uh-oh, that's not cool. We have a grid that's out now. That's because I desoldered something, and yes, I desoldered a diode back here. Let's fix that right now. Good thing it reminds me. Okay. There we go. There. We got one pointer. Let's go through the band. Working as it should. Can you see that? There's no glare. Alright. Looks like the display is now working 100%. Alright, now that we have our display, our messed up display fixed, let's see, let's do a final test. Let's see if we have our FM stereo back, because that one's kind of curious to me. It might be just a simple adjustment, or it might be a involved fix. So let's turn this thing on. Plug it in first. I always forget that. Yes, here we go.
$30 Big Brothers Big Sisters Dream Home
Look at
Lottery
that, we're
ticket
greeted with
isn't
a
just
station already.
It's hope. It's support.
104, I
It's a
think
brand new
there's
for a child. Win the dream home valued at a life-changing
Auto.
$1.27 million. Or take your shot at winning up to $1 million with Win 50.
So we still have no stereo. It might be a simple. Oh, there we go. No, it should pick it up on every station, not just one. There we go, 2 stations.
The whistle, the firework, the crack in the trees, the screams of the crowd.
We might just have a simple adjustment here. It seems like it's coming in. Now it's working.
To Go RV, home of the... It's an actual worry.
Let's see if we can do some memory stuff here. FM. Let's go find some weaker stations and we'll see if the stereo is still working.
97. Sweetheart, Prairie Rock.
Not that one. 96.3. No stereo. $88.5. There's our station indicator. Our memory select is showing up, which is good. Another one there. $92.5. No stereo. Okay. So we might have just a little adjustment. Stereo is working, but it seems to have trouble picking it up. I have a feeling I know why. Probably there's a 76 kilohertz oscillator in the multiplex chip, and if that's not tuned to 76 kilohertz, it'll have problems picking up the stereo beacon. What they do is they take the 76 kilohertz and divide it down to 19 kilohertz.
Of course, overdrive.
Let's do this one. Station. Let's do 102.9.
Cuisine, along with family activities and giveaways. Experience
Okay,
Southeast
so there's our 5
culinary delights.
presets for FM. Let's try AM. Come on. Taking its sweet time.
Ugly host of demons, humanity will be humbled, Christ will be exalted. It will be the greatest event since the...
I went back to the... Might have a problem with these switches. I don't know.
in the perfect tense, which means they have been standing in the... They wait. David
Pecker will return to the...
Coldly.
to make air travel prohibitively expensive. When I don't know the specifics. Regardless, let's say it was everywhere. That's the city of council. To cut back on travel, it would be political suicide. So it's
Something seems messed up with these presets. Trying to figure out what it is. It's going to load them up. That one didn't take. It's not showing up.
It's just more complicated. With difficulty in any.
Yeah, but the indicator is not showing up. For some reason, we don't have an indicator for 880.
For a limited time, make the 2024 RAV4 LE all-wheel drive from $96 with
900.
months at 5.4
880's there.
747 and 683-749. CFCW, a stingray radio station, broadcasting on Treaty 6 territory from Canberra and West Edmonton Mall. Download the free Stingray.
Something is wrong with that. Memory stuck.
See your rights and the law. No one ever deserves.
Okay. Everything's working. Alright, here's a look at the multiplex circuit. It's all done within the chip IC301, which is CX, it's a Sony chip, CX17, or sorry, CX178, and this is the 76 kilohertz VCO, voltage controlled oscillator, and it's controlled by this resistance. This resistance here controls that oscillator. So this is our 76 kilohertz adjustment. I think what they want us to do is hook up our frequency counter to pin 13 and adjust this so that we have 76 kilohertz. That's what it looks like to me. Let me see if I can find. Okay, here's the procedure for 76 kilohertz adjustment. Regular method is to use FM signal generator at 98 megahertz, modulated 400 hertz, 75 kilohertz deviation, 100% modulation. Strong signal going into the set. And then hook up a frequency counter through 100 k ohm resistor to pin 13 and adjust RV301. And then there's a simple method, which is tune this set to an FM stereo signal, and then turn RV301 back and forth until the stereo lamp comes on, and then you just set it into the middle of the range where the lamp lights up. It seems simple enough if you don't need any equipment. But I'm going to do it the other way. I'm going to get the frequency counter going and try it this way, right on pin 13. I might have to tack something on there to hook onto. I'll just tack a 100k resistor onto pin 13. Alright, so I got my 100k resistor tacked on to pin 13. I'm going to turn this thing on. And we are on. You can hear the interstation static. My signal generator set to 98 megahertz, and we're going to turn up the signal. And 76 kilohertz is doing not too good. It's down at 78 kilohertz. So let me tweak this up. Okay, so let me turn down the volume here. You don't hear that noise. And let's see what potentiometer I need to turn is where is it? 301. Where is 301? Let me check where 301 is just to make sure. Okay, 301 should be this one here. So let's try cranking on this one. Okay, went down. 76 kilohertz. Try turning it. Let's let it stabilize here. That trim pot might be a little dirty. Okay. We're still. Turn it down a bit. There we go. Oh, still. It's actually not bad right there. I think I might just leave it at that. We're getting better. Alright, so I put the bottom plate on because I'm pretty confident we're done. Let's turn this thing on. Oh, we're getting stereo on my weakest station now. That's AM. What am I doing here? Stereo? 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 Everything's working stereo now. It's a nice tuner.
Everyone has a big to
It's got good separation. Good signal. Picking everything up. It's also picking up a lot of interference. Everything's working good.
I just got this text. Yeah, Mini, great.
0% interest financing.
And of course you can make it mute.
Yeah, we're getting stereo on all our stations now.
I swear to God, I don't throw that word.
This one's always mono. So the big story for this one was a lot of dead caps in here. I would say, let's see, yeah, a lot of dead caps, high ESR, down in value, dried out. These are Elnas. These are not the gray Elnas, these are the dark purple Elnas. The other big part of the story here is we replaced the soldered in battery with a battery holder and provided easy replacement for the future owner. We got rid of some bodges, and then we had to do a repair on the display, which was my cock up. I actually had I was cutting off long leads and one of the little cutoffs fell into the circuit and shorted it out. So that's my doing. So lost about an hour or two doing that. And the other thing about this was the VCO on the multiplex circuit was out of tune, so we had to tune that back into before we could get stereo again. So everything's good. So this is a very nice tuner. I really enjoyed working on it. The main thing I like about this tuner, working on this tuner, was the service manual. It's phenomenal. There's so much information packed in there, and it helped me quite a bit, especially when I was diagnosing the display. So, that's it for this one. I'm pretty sure that the owner will be happy with it, and I hope he's pleased with the end result. I'm sure he will be, and I'm going to get this back to him so he can start enjoying it. So take care, and we'll talk to you on the next one. Thanks for watching.
What can I